So very good morning. So this for today's session, we are going to speak about one type of modulation technique called as an pulse modulation. Okay, now when you speak, what exactly is basically is a modulation there? You know, when you speak about the modulation, no modulation, it's a process of wherein we ask the high frequency signals to carry our information, because we all know that the information or what we have, or the audio signal what we have is is in the audio frequency range, which is the maximum is 20 kilohertz, and these 20 kilohertz of signal cannot travel a longer distance, so therefore we go for a modulation. Now modulation is a process in which any one of the parameter of the carrier signal is varied with respect to the modulating signal by keeping the other parameters constant there. Okay, now so we all know about the analog modulation technique. So analog modulation technique where the modulating signal is an analog signal, the carrier signal is also an analog signal, and the modulated signal is also an analog signal. Okay, now depending upon what type of carrier signal we are using, so we can have a special type of modulation called as an pulse modulation. Now, in this pulse modulation, we make use of an pulses as our carrier signal. We make use of pulses as our carrier signal. So therefore, we call this as an pulse modulation. So in a pulse modulation, the carrier signal is a discrete pulse train. So instead of an analog signal. Now, when you speak about the pulses, discrete pulse there, no, so same here, the definition of modulation is same here. So we are going to change any one of the parameter of these discrete pulses with respect to the modulating signal. Now, when we speak about the discrete pulses, now what are the parameters of these discrete pulses? So the parameters is either I can change the amplitude of the pulses, or I can change the width of the pulses. So when I tell the width, it's on time of the pulse, or I can change the position of the pulses. Now position when we speak, the starting point of the pulses there. So therefore, I can tell that, so here, so I'll vary any one of the parameter of the pulses there. Either I'll vary the amplitude of the pulses, or I'll vary the width of the pulse, or I will vary the position of the pulse by keeping the other parameters constant. And this type of modulation, we call it as a pulse modulation. So the modulating signal will vary any one of the parameter of the rectangular pulses or the carrier with respect and by keeping the other parameters constant. And this type of modulation, we call it as a pulse modulation. Now, depending upon the parameters that we are varying, now this pulse modulation can be classified into two different types. So one is called as analog pulse modulation, the other one is called as a digital pulse modulation. Okay, now so today we are going to speak about the analog pulse modulation. So in the analog pulse modulation, so what will happen here is, so the what do you call the signal, input signal is the modulating signal is analog in nature, and whereas in digital pulse modulation the modulating signal is analog in nature, but the output will be in the digital format. So digital pulse model, analog pulse modulation, so we have got three types of analog pulse modulating signal. So one, we call it as a pulse amplitude modulation, or in short we call it as PAM, so pulse amplitude modulation. Next we have pulse width modulation, so we call it as a PWM, and then we have pulse position modulation, we call it as a PPM. Now, digital pulse modulation can be further classified into as pulse code modulation. In short, we call it as a PCM, and differential pulse code modulation, we call it as DPCM, and at last we have a delta modulation, we call it as DMD. So in this particular session, we are going to discuss about analog pulse modulation techniques. So that is pulse amplitude modulation, pulse width modulation, and pulse position modulation. So we'll take the first type of modulation called as a pulse amplitude modulation. Now, when I tell pulse amplitude modulation, as the name indicates that I am going to change the amplitude of the pulses. I'm going to change the amplitude of the pulses with respect to the modulating signal by keeping the width and position constant. By keeping the width and position constant, I'm going to change the amplitude of the pulses. Now, that type of modulation, we call it as a pulse amplitude modulation. So the definition of pulse amplitude modulation equals the amplitude of the carrier pulses is varied with respect to the modulating signal by keeping the width and position constant. So here in the picture you can see that this is a modulating signal and this is a carrier signal, and I said that the carrier signal will be in rectangular pulse. In pulse amplitude modulation you can see that the amplitude of these pulses is varied with respect to the modulating signal. So when the modulating signal voltage increases, even here, the amplitude of the pulse is also increased. Amplitude is increasing further, the amplitude of this pulse is increased further. The amplitude is decreasing now, so even here the amplitude is decreasing. So the amplitude is decreasing to the negative value. So even here the amplitude of these pulses are with respect to the negative value. So here you can see that the amplitude of these carrier pulses are varied with respect to the modulating signal by keeping the width constant. You can see that the width of the pulses is constant all the time. Okay, now whatever the images we are using in this particular presentation, it is been downloaded or it is been used from the internet, which is available. These images are available on the internet. So the sources of these images is from internet there. Okay, now next is your pulse width modulation. The next type of modulation is pulse width modulation. So here we are going to change the width of the pulses or width of the carrier pulses with respect to the modulating signal by keeping the amplitude and position constant. In the previous case, we were changing the amplitude of the pulses, but here we will change the width of the pulses. We will change the width of the pulses with respect to the modulating signal. So therefore, we call this as a pulse width modulation. So this is a diagram of a pulse width modulation. So even here you can see that we have got an analog signal, which is a modulating signal, and this is your rectangular pulses. Now here what we do in pulse width modulation is the on time of the pulses. You can see that the on time of the pulses is varied with respect to the modulating signal. So we'll see one by one. So the first case, so the model voltage is 0, so the amplitude will be same as the carrier signal. In the second case, so the amplitude of the modulating signal is increased. So you can see that the width of the signal is also increased. The modulated signal width is also more. Third case, the voltage of modulating signal is maximum. So the width, you can see that even the width is also maximum. Fourth case, the modulating voltage is decreasing. Again, you can see that the width is decreasing. Next, the modulating voltage is decreasing, the width is also decreasing. Here, the modulating voltage is at the minimum, negative minimum, so or negative maximum. So therefore, we can consider as that as a minimum value. So therefore, you can see that the width is also minimum. Again, when the modulating voltage increases, the width is also increasing. And this type of modulation, you can see that we call it as a pulse width modulation. And you can see that in this pulse width modulation, the amplitude of the pulses is constant, and the starting point of the pulses is also constant. We are not changing the starting point, it is with respect to the carrier signal itself. Only thing what we are changing here is the width of the pulses. So therefore this type of modulation we call it as a pulse width modulation. Now, so I can define a pulse width modulation. It's a type of pulse modulation technique in which width of the carrier signal is varied with respect to the modulating signal by keeping the amplitude and position constant. Next, we have got the next type of modulation called as a pulse position modulation. So in this modulation, I can define this type of modulation as it's a type of modulation technique in which position of the pulses is varied with respect to the modulating signal by keeping the amplitude and width constant. So here we'll keep the amplitude and width constant. So we'll see the diagram. So here you can see that this is your modulating signal. This is my modulating signal and this is the carrier signal. So here what I do is I'll try to change the position of this carrier signal with respect to the modulating signal. So if the modulating voltage is more, then the distance between the two pulses has to be more. When the modulating voltage is less, the distance between the two pulses will also be less. So here you can see that before modulation, we have got a carrier signal whose the distance between the pulses is constant, the amplitude of the pulses is constant. We'll see what will happen after pulse position modulation. So now this pulse position modulation can be obtained from pulse width modulation. So first we obtain the pulse width modulation. So you can see that, so we are getting the pulse, as the modulating voltage is increasing, the width of the pulses is also increasing. So here the modulating voltage is maximum, the width is also maximum. The modulating voltage is decreasing, the width will also decrease. The modulating voltage is decreasing, the width will also decrease. Here it is minimum, the width will also be minimum. This is PWM. Now from the PWM, during the trailing edge of the pulse of PWM, during the trailing edge of the PWM, we try to generate one pulse. The trailing edge, we try to generate one pulse. The trailing edge, we try to generate the pulse. Now, so here you can see that the gap between, or the distance between the pulses is not uniform. So when the modulating voltage is increasing, the distance between the starting point of the pulses will also change. It will be varying, or the gap distance between the consecutive pulses will be more. When the modulating voltage decreases, the distance between the consecutive pulses will also decrease. Now this type of modulation we call it as a pulse position modulation. So therefore I can define as a pulse position modulation. It's a type of modulation technique in which position of the pulses is varied with respect to the modulating signal by keeping the amplitude and width constant. So this is for this particular presentation now. So in the next presentation, we'll discuss about the other type of modulation technique. So that is pulse code modulation, differential pulse code modulation, and delta modulation. So thank you.